We are solving a question regarding forces and equilibrium. A ring of mass 4 kg is threaded on a smooth, circular, rigid wire with a center C. The wire is fixed on a vertical plane and the ring is kept at rest by the light inextensible string connected at the point A, which is the highest point above the circle. The string makes an angle of 25 degrees to the vertical. Find the tension in the string and the magnitude of the normal reactional force of the wire on the ring. So, there is a ring, circular ring, where the highest point is A and it is at this position where mass of that thing is 4 kg and it is the highest point in the ring there. Let's say that is O. Now we know one thing, that if this point is B, you join, and this angle is 25 is the figure given there. If we join O with B, then it will become the radius. So this angle is also equal to 25 degrees. Now we have to find out the radius and the tangent in that string there. Here, this is the tangent T. We know that this is the tangent to that circle, which makes an angle of 90 degree to that at the point B there. So it is 25, and if we join this one, the radial component, this is the weight, and that is equal to 40 Newton because mass is 4 kg there. Now, if it is 25, then this angle is also equal to 25 due to alternate angles of this position. So we are going to resolve these components, and here it is the normal, because we know that the normal contact force is always perpendicular to the surface of the motion there. So it is making an angle of 90 degree at this position, at the point B there. Now, this is 25, this is 25, so this total angle will be of 50 degree. So if it is 50 degree, then due to the vertical opposite angle, this angle is also equal to 50 degree. Now we are going to find out the components. If this one is the tension T there, then there are two components of this tension. One is known as to be called T sine of 25, and this component will come T cos of 25. And if we resolve this R into components, we know that this component would be R cos of 50, and this component would be equal to R sine of 50. Since the whole system is in equilibrium, so in this all vertical forces are balanced as well as all horizontal forces are balanced. So vertical forces due to this part is this T cos of 25, that is equal to R sine R cos of 50 plus this 40. Let's say it is equation number 1. Then we have to solve the horizontal components. In this case, the horizontal component is this R sine of 50 towards the left side. And it is equal to the right side of this one is T cos of 25. So let's say that is equation number 2. Now we have to solve 1 and 2 simultaneously with respect to each of this part. So by taking from this t as a subject, so t should be equal to r sine of 50 over sine of 25. And now we put this value of t into this 1, then it should be equal to r sine of 50 over sine of 25 into cos of 25 is equal to r cos of 50 plus 40. Now from this we can make r as a subject, r sine of 50 over sine of 25 into cos of 25 minus r cos of 50 is equal to 40. We can take r as subject, sine of 50 into cos 25 over sine 25 minus r is common there, cos of 50, and that is equal to 40. If we do the calculation of all this, then r value is equal to 40 Newton. Now, the value of t from this portion is, from this third, we can say that t is equal to r sine of 50 over sine of 25, but r value is equal to 40 into sine 50 over sine 25. So t value is equal to 72.5. So this is the value of tension and this is the value of R there. So these are the values which are going to be calculated from this example of this circular part with the equilibrium of the forces there.